try this example. You are asked to expand these functions in ascending power of x as far as the term in x power 3 by using the binomial theorem. Also, you are asked to determine the limits of x where the expansion is valid. To solve these questions, write down the functions and rewrite it in this manner. Divisions of the function's power of 2 can be rewritten in the form of power of -2. For easy applications of the formulas for binomial series, you may try to rewrite the functions so that the a is equals to 1. Take out the factor 4 here, which will be 1 minus x per 4. The entire function here is to be power of -2. Take out this with the power of -2, you will get this. Now you have a function where the a is equals to 1, the x is equals to -x per 4, and the n will be equals to -2. As given here. Substitute the relevant value into the formula, you will get this, which after simplifications, you will get this. This expansion is valid when the term x here is between the range of -1 to 1, which can be rewritten in the form of modulus x per 4 less than 1, which after rearranging, you will get modulus x has to be less than 4. Let us try this example. The questions ask you to use the binomial theorem to expand these functions in ascending power of x to 4 terms. You are also asked to give the limits of x which the expansion is valid. To solve this, copy down the solutions here. Based on the solution here, you can actually use a equals to 4 and x is equals to x. And the n here will be equals to 1 per 2. And substitute into the formulas of the binomial theorems. The calculation step will be slightly longer because the a here is not equals to 1. Then you will need to compute the a power of n throughout the equations. The solution here gives another alternative where you can set a equals to 1 so that it will speed up your calculations for the binomial theorems. To do so, you will need to factorize and take out the 4 from the functions here. By taking out the 4 here, that will be equals to 1 plus x divided by 4. These functions can be separated into square root of 4 and the square root of these functions. Square root of 4 will be equals to 2. And these functions can be rewritten in the form of 1 plus x per 4 power of 1 per 2. Now by looking at the structures of the functions, you know that a is equals to 1 and x will be equals to x per 4 and n will be equals to 1 per 2. So these functions will ultimately equals to 2 times the expansions of the binomial formulas. Substitute the a, x and n into the formula here, that gives you this. Simplify the solutions, you get this.
Then your next step is to determine the limits of x where the expression is valid. For it to be valid, the modulus of the x here needs to be less than 1.0 as written here. If you move the 4 to the opposite side, so your x should fall between -4 to 4.